APL, an interpreted array-based functional programming language famous for its reliance on unusual Unicode characters. It was developed in 1962 by Kenneth Iverson as a way to bring mathematical notation to computer science. Instead of reserved names, every built-in function or operator is represented with just a single character. This means that code that would take up a dozen lines in another language can be written in just one line of APL. APL is used, for example, in DNA profiling, where code needs to be written fast, but not necessarily reused. To get started, install the APL interpreter from Dialog and create a file ending in .apl. Or if you just want to mess around, go to tryapl.org for a simple interpreter. APL's design philosophy is that you should focus on the problem at hand instead of how to explain it to the computer. Part of this is that instead of having a ton of different types, APL just has two: numbers and strings. If you want an array, just put spaces between multiple literals and then assign it to a variable with the left-facing arrow. Any operation performed on this array will automatically be mapped to every element of it, avoiding any need for explicit iteration. Most built-in symbols can be used in multiple different yet related ways. A function's monadic form takes one argument, everything to its right, and does something to it. In its dyadic form, it also takes its immediate left neighbor as a second argument. This means that APL programs are read from right to left without any regard for PEMDAS. You can compose certain operators to construct more complex behavior. For example, to sum every number between 1 and 10, use the monadic iota operator, which generates an array of every integer between 1 and the provided argument. You can then compose add and reduce to create the sum operator. In functional programming, reduce can be read as simply placing an operator between every element of an array. When you apply a comparative operator to an array, you get a list of ones and zeros called a bit mask. This can then be used to filter out values of an array corresponding to the zeros. Define a function with braces. Reference the right argument with the omega symbol, and optionally the left one using the alpha symbol. The result of this expression will be automatically returned. APL supports multidimensional arrays. To get one, you could use the shape operand to format a 1D array into a matrix or higher dimension. You could also compose the outer product with a dyadic operator, then pass it to arrays to generate a combinatory grid. As with 1D arrays, any operation performed on a multidimensional table will be automatically mapped to every single element within. This has been a bite of APL. I hope you enjoyed, and I'll see you in the next one.